Hi, this is Ms. Delosier, and these are your notes on speed and velocity. You should already have a double bubble map ready to go, drawn to go ahead and start this. If you don't, go ahead and copy that down from the Quest on 3D Game Lab. This is the bubble map, and we're going to talk about fast, like an airplane, and we're going to talk about slow, like a snail. So I think that we all know that when we're talking about speed, we're talking about how fast an object is moving. So what does that really mean? And that's really what we're going to be talking about. So how fast an object is moving. And that's something that both speed and velocity have in common. They are both rates. Rates of the distance an object has moved divided by the time that it took to get there. And we typically are going to measure those in meters per second, but not always, but normally meters per second in physics class. We'll do a couple examples that are in miles per hour, miles per minute, just because those are more comfortable for us as we get started. So as we go ahead and get started, let's talk about speed, because that's something we're more familiar with. So speed is a measure of the rate a distance is traveled. So what does that mean? That means how long did it take me to get from point A to point B? So the total distance that I went. So let's say that I get in the car and I drive from school down to Walmart and then back. So let's say that that's a half mile. So I traveled there and then I traveled back. So I went a mile and it took me 5 minutes. So I went 1 mile in 5 minutes. So I could use that to go ahead and do my distance divided by my time, and I could find my speed, and that's just d divided by delta t. Now remember, the delta, the triangle, means the change in, so what's my total time? And this is a scalar quantity. A scalar is just a measurement that only includes a magnitude and a unit. So I have a number like 1 mile. So 1 is my number, my magnitude, and my unit there would be a mile. And then I would have that per minute, or per 5 minutes in this case. So if I went 1 mile in 5 minutes, my rate would be 1 divided by 5, which would be 0.2 miles per minute. Okay, so that is an example of speed. I use my distance, the total distance that I traveled. My car went from school to Walmart, back to school. So everything that I traveled. Now we're going to contrast that to velocity, and velocity is a little different, because velocity is going to be a rate an object changes the position. So now let's take that same example. I start at school, I go to Walmart, I come back to school. So my starting position and my ending position are both school. So what's the total position change? Which that's displacement, right? The total position change there, my displacement there, how far am I from where I started, is actually 0 miles. I didn't go anywhere. I'm still at school. So in order to solve for velocity, we're going to go ahead and we're going to do our displacement divided by our time. Now, you'll notice that displacement and distance both begin with d, and time is still time. So my formula is still going to be d over delta t. And frequently you'll also see that as the change in d over the change in t. So these formulas are going to be calculated using the same equation, but what you need to do is you need to check and see, am I calculating speed and am I using my total distance, or am I calculating velocity and I'm using my displacement instead? So you have to be very careful what the problem's asking you for. Now, how else are they different? Velocity is a vector, and you may remember that vectors include some type of direction, because we talked about that with displacement. So that's very important. That is the primary difference. If somebody says, what's the difference between speed and velocity, the first thing you should say is velocity includes direction. The second thing you should say is velocity is calculated using displacement. Okay, so let's give you a couple examples of when we use the word speed or velocity in everyday language. You might hear the term instantaneous speed or instantaneous velocity, and that's basically your speed at that split second in time. So an example would be your speedometer. So if I'm in the car and I'm going 60 miles per hour, I look down at my speedometer, it says 60. That's how fast I'm going right then. That doesn't mean that's how fast I'm going the whole time. That's just what does the speedometer say right at that moment. Okay? You could also have what's called a constant speed. And that means that basically you're on cruise control. That's really the only way you're going to have a constant speed is if you take your vehicle and you set it at a constant speed. Because if you think about it, like even walking through the hallway, you're not walking at a constant speed. But sometimes we like to talk about constant speed when we do our calculations just because it simplifies things. So let's look at a practice problem. We're going to look at speed and velocity for this problem. So if you look, we have a skier, and the skier is at positions A, B, C, and D, and they're going to travel from A to B to C to D. And we're going to actually calculate the speed first, and then we'll calculate the velocity. So let's start with speed. So speed is delta D divided by delta T. Velocity is also delta D divided by delta T. Remember that the velocity is the displacement, the change in the displacement, and the speed is the change in distance. And if you forgot that little delta right there, that just means the change in. So how far did I go? So we're going to look at that first for distance. So what is my distance? So I'm going to go ahead, and first I'm going to go ahead and travel from A to B. And that's one long pass, and that is going to be 40 plus 100 plus 40. So that's 180. And then I'm going to go back from B to C. And that's the 40 and the 100, so I went 140. And then I go back to D, and that is just that one little section, so that is 100. So in order to find my distance, I'm just going to take those three distances that I traveled, and I'm just going to add them together. So 180 plus 140 plus 100 equals 420 meters. My time, if you look up there, is I went 0 minute, 1 minute, 2 minute, 3 minutes. So my total time is just 3 minutes. That's pretty easy. Now, in order to go ahead and calculate this, I'm just going to do my change in distance, 420 meters, divided by my change in time. So that's going to be S equals delta D, change in distance, over change in time. 420 over 3 is going to give me a total speed of 140 meters per minute. That's pretty simple, right? Most of you probably could have calculated that after I explained the picture. I know the picture is pretty tricky. So let's look at the velocity. I'm going to have delta D, change in distance. Now here, I could just look at the picture because I have the picture drawn and go from x1, my initial x position, to xf, my final x position. I went from the A skier to the D skier. And I can look at that number line and I can see that I just went 140 meters. Okay? And it's 140 meters to the right, by the way, because you have to give it a distance. But sometimes it's not that clear cut because they don't give you a picture. So if they don't give you a picture, we have to look. Let's say I told you I went 180 meters to the right. Then I went 140 to the left. Then I went 100 to the right. Okay, well, I'm going to go ahead and I'm going to say going to the right is positive, going to the left is negative. So that's positive, negative, positive. And when I add those together, I get 140 to the right, which is the same thing that I got just by looking at the picture. So remember, you can always go ahead and you can calculate your displacement by drawing the arrows back and forth and just seeing what's the total distance from the initial point to the final point, because that's your displacement, okay? Now my time didn't change. My change in time is still 3 minutes. So my velocity, delta D, change in displacement, over delta T, change in time, is simply going to be 140 meters to the right over 3 minutes, which gives you the average velocity, which is 46.7 meters per minute, and I have to provide a direction. So my overall direction here is to the right. And frequently you'll just go ahead and see that listed as an arrow. They'll just draw an arrow to the right indicating the direction. Hopefully that makes sense. If you're still having trouble going ahead and calculating displacement, you might want to go ahead and review the notes. If you're not quite sure what the triangle means, just come chat with me and we'll go ahead and go through a couple other examples. So go ahead and submit your request and move on to the next one.